Namaste. In this video, we will learn paper chromatography. At the end of the video, you will be able to explain the principle involved in the separation by paper chromatography, various developmental techniques that are used in paper chromatography, calculation of retention factor, that is RF value, and application of paper chromatography. Paper chromatography is a planar chromatographic technique. In this, the separation is achieved on a planar surface by the flow of mobile phase on specially designed filter paper. Since in the separation by paper chromatography, paper is used for separation, what must be the principle involved in the separation of the components? Here, I will like that you all pause the video and write your opinion for the principle of separation on paper. If you are ready with the answer, let us resume back the video. Principle of separation in paper chromatography is based on partitioning phenomena. Whenever we use the word partitioning, it is related with the solubility. Now the filter paper which we are using in the separation is made up of cellulose. Due to the absorbent nature of cellulose, this paper always contains a thin layer of moisture on it. This layer might not be seen with the naked eyes, however it always exists, and this acts as the liquid stationary phase. The components of the mixture are now separated based on their solubilities in the liquid stationary phase, that is the water layer on the paper, and the mobile phase that is employed in the separation. Let us now look at the various steps involved in the paper chromatographic separation. In any of the chromatography, the most important point is selection of the stationary phase. Now since this is paper chromatography, a suitable paper is taken. Mobile phase is then selected and prepared. That totally depends on which compounds are to be separated. After the mobile phase is prepared, we have to simultaneously take the paper, take the sample in the solution form and apply it on the paper with the help of fine capillary or micropipette. For the development, this paper is now to be taken to the chromatographic chamber, which is previously saturated with the vapors of mobile phase. After the development is complete, we have to dry the paper and locate the spots on the paper. This paper is now used for qualitative and quantitative estimation. Let us look at the steps involved in paper chromatography with the help of diagram. Initially, a chromatographic chamber is taken. In this, required quantity of mobile phase is added and it is kept covered for the saturation purpose. Now simultaneously, the paper is taken. On the paper, a line is marked where sample is to be applied. The sample is now applied with the help of fine capillary or micropipette on the paper. The sample has to be in the clear solution form. This paper on which the sample is applied is now placed in the already saturated chromatographic chamber and the chamber is covered with lid. This chamber is now kept undisturbed for some period of time for the development of the chromatogram. During this, it is necessary that we do monitor the movement of the solvent front. Now let us see how the separation takes place. The sample which is applied might be containing 2 or 3 samples. These will have different solubilities in water and the mobile phase which is used. So depending upon their solubility, they do travel different distances. The component having more solubility in the water, that is indicated with the orange colored spot, will be retained immediately. On the other hand, the component which is denoted with blue color might be having lesser solubility in the water, so it travels a further distance in the mobile phase, and that is why the separation is totally based on the solubilities of the components in the water and the mobile phase which is employed in the development. Now let us see which are the different developmental techniques in paper chromatography. So paper chromatography can be performed by 4 basic techniques. The first and the simplest one is ascending technique. As the name indicates, here the mobile phase travels in the upward direction or in the ascending in direction as indicated with the arrow. Opposite to this is the second type, that is descending chromatography or descending technique. As the name indicates, this technique involves the movement of the mobile phase in the downward direction or descending direction. Combination of ascending and descending technique is done in the next type of development, where the paper is folded like this and used for the separation purpose. Now here the mobile phase travels in the directions which are indicated by, you can see the mobile phase first travels in the upward direction and then it travels in the downward direction. In this case, this is called as ascending descending technique, where we have the mobile phase traveling in ascending as well as descending directions. The last type of chromatographic development is circular chromatography. As the name indicates, the separation here takes place on the paper which is used in the circular form. This is called as circular chromatography. In this case, the sample is applied at the center. This filter paper which is used is having a wick in it which is dipped in the mobile phase, taken in a suitable shape chamber. The chromatographic development takes place now, where the sample travels from its center towards the circumference of the paper. So these are different developmental techniques in paper chromatography. Now let us understand about the location of spots. If the sample contains colored components, they can be easily visualized. However, if the sample contains the components which do not have color, the paper looks something like this, where we are not able to see anything on the paper. In this case, we have to apply it a suitable spray. For that, a spraying bottle is used and a reagent is sprayed on the paper. That results in some type of chemical reaction which finally gives the paper like this, where these types of spots are developed by reaction between the components and this spraying agent which is used. Once the spots are developed, in case of paper chromatography, we have to calculate the retention factor, that is RF value. This RF value is a very important parameter which is employed in the identification of the compound. This can be clearly seen from this. Let us understand, this is one of the paper on which the sample has moved. This spot indicates this sample. Now the distance x is the distance travelled by the solvent front from the line of application, and distance y is the distance travelled by the component or the solute. In this case, the RF value is calculated by the formula distance travelled by solute divided by distance travelled by the solvent front. Thus, in this diagram, the RF value will be given as Y upon X. Let us understand now the applications of paper chromatography. This paper chromatography can be used for qualitative analysis. This analysis is based on RF value. Here, the standard is applied and the sample is also applied. If after the development, the distances travelled by both the standard and the sample are same under the similar chromatographic conditions, we can very well say that this sample is nothing but the standard. Thus, identification of unknown compound is possible. The chromatography can also be used for quantitative purpose. Here, the area of the spot which is obtained after the chromatographic development is taken into consideration. The areas of the sample and that of the standard are compared, and depending upon these areas, finally the quantitative estimation is carried out. Now let's do a small activity. If a mixture of compounds X and Y is separated by paper chromatography using methanol as the mobile phase, the solvent front is allowed to travel up to 10 cm on the paper. Calculate the RF values for X and Y if the distance travelled by X and Y on the paper is 3 cm and 6 cm respectively. I request everyone to please pause the video and do the calculations. Now if you are ready with the calculation, let's resume back to our video. So here, since X has travelled a distance 3 cm and the solvent front has travelled a distance of 10 cm, RF value of X is given as 3 upon 10, that is distance travelled by X divided by distance travelled by solvent front. In a similar way, RF value of Y can be obtained as 0.6. So here in this video, we have understood how the separation of the compounds takes place in paper chromatography. We need to remember that the separation is based on solubility in the water and the mobile phase. RF value can be calculated, which helps in the qualitative analysis of the compound. Remember, the RF value is always less than 1. So with this, we end with the video. Thank you for the patient listening. Thank you. Happy learning.